guys, welcome back to my channel. I am Rishita, currently pursuing BE Sri Venkateshwara College of Engineering, Department of Electronics and Communication. My USN is 1VE22EC090. Today let's discuss on the topic of Lagrange's interpolation. Introduction. Lagrange's interpolation is a mathematical method used to estimate values between known data points. It was developed by the Geoffrey Louis Lagranges in the latest 18th century. This method is used on the constructing a polynomial function that pass throughout the given data points. As you can see, this is a formula of Lagrange's interpolation. Lagrange's polymers. Lagrange's polymers is a polymer function used in the Lagrange's interpolation. It is defined as the sum of the product of a given data point, a point and the set of basic polymers. The basic polymers are constructed using the Lagrange's basic function. Lagrange's basic function are used to construct the Lagrange's polymers. Each basic function is associated with the specific data points and it's equal to the 1 at that point and 0 at the other point. The Lagrange's basic function are typically denoted by L0x, where I is an index of an associated data point. Interpolation errors. There are some errors in the interpolation. Interpolation errors refers to the difference between actual function value and the estimate value obtained throughout the Lagrange's interpolation. The error depends on the number of data points used and the behavior of the actual function. As the number of data points increased, the interpolation error generally decreases. When the data points increases, interpolation errors generally decreases. Some advantages of this Lagrange's interpolation. Lagrange's interpolation is a simple and innovative method. It can be used for both numerical and graphical representation of data. The method is applicable for any number of data points. Disadvantages of the Lagrange's interpolation. Calculation of a Lagrange's interpolation can be computationally expensive for the large number of data points. The method can be sensitive to the placements of data points, leading to the potential across issues. Interpolation function with high degree of a complexity can result in the oscillation or the instability. Lagrange's formula, as I said before in the slide, Lagrange's formula is used to calculate the value of the Lagrange's polynomials at the given point x. The formula involves summary the product of the v value of the given data points at the corresponding Lagrange's basic function evaluated at the x. The Lagrange's polymers is then obtained as a sum of this product. Some example of Lagrange's interpolation are: let's consider the set of data points as 1, 2, 3, 4 and 5, 6. Using this Lagrange's interpolation, we can estimate the value of f by 2 given the data points. Calculating the Lagrange's polymers of these data points, we can find f of 2 is equals to 2.8. Similarly, the second example. Now, let's consider the data points as -1, 1, 0, 0, 1, 1 and 2, 4. We went to establish the value of f, 0.5 using the Lagrange's interpolation. By calculating the Lagrange's polymers, we find f is equals 0.5 is equals to 0.625. Some applications of Lagrange's interpolation. Lagrange's interpolation has a various application in the science, engineering and finance. It plays in the very important role in these fields like science, engineering and the finance field. It can be used in the numerical analysis to approximately known as function. The method is also employed in the compute graphical and imagine progressing for the data reconstruction. Alternate to the Lagrange's interpolation. Other interpolation methods such as Newton's division, difference and the split interpolation are commonly used to alternate the Lagrange's interpolation. This method may offer advantages in the terms of computational effectiveness and the certain situations. The choice of interpolation method depends upon the specific requirements on the problem. It depends on the problem handed things. At last, the summary of the Lagrange's interpolation. Lagrange's interpolation is a mathematical method for estimating value between known data points. It involves construction of polymer function that passes through the given data points. The method has advantages in specifying and applicable but can be computably effective for the large data sets. As you can see in this picture, this is the largest polymers of n, 3. And this is a formula of Lagrange's interpolation where it deals with the y is equals to x0, x1, x3 and so on till xn. Be the value of the function f is equals to f of x, y is equals to f of x corresponded to the point x is equals to same as x0, x1, x2 and so on x0, xn. Not necessary to equal space. The formula is f of x is equals to x minus x1, x1 and x minus x2 so on x minus x0. x0 minus x1, x0 minus x2 and so on x0 minus x0. f of x0 plus f x minus x0, x minus x0, x minus x0, x minus 1, x minus x0, x1 minus x2, so on x1 minus x0. f of x1, as it's go on so on till the f of x0. Thank you guys. Please do support